Hi everybody, so for today we will go further into the gravity world. Gravity is a force that pulls all objects toward each other. The force that attracts every object within this universe is called as gravitational force. For information, it is one of the fundamental forces in nature. As shown before, the scene of the durian fell on the ground is the simplest example of gravity. In addition, this force will also keep the moon orbiting the earth. This is because Newton realized that gravity acts everywhere, not just on earth. Newton's laws are grouped into three laws, which are the first law, the second law, and the third law. But this time for gravity, we will focus only on two laws, which are the first law and the second law. First law talks about inertia, where an object at rest will stay at rest, while an object in motion will stay in motion with constant velocity unless acted upon by an unbalanced force. As the law stated, an object at rest will stay at rest. So I'll pull off this money and this bottle of sauce will remain. Okay. 1, 2, 3. Example of inertia is when you wanna pour some sauce, it won't go up like this. But you have to shake it, then it will go up, just like that. The second law talks about force equal to mass times acceleration. As an example, here I have two objects with different mass, this tissue and this toys. This tissue, which is lighter, will fall slowly, and these toys will fall faster. This is because the gravitational force that acts on the toys is much bigger than the tissue. Wait, not to forget to mention that this gravitational force strength is influenced by two factors, which are mass of objects and the distance between the objects. As mass increases, the gravitational force also increases because it is directly proportional to their masses. For the distance, it is inversely proportional to the square of the distance between the bodies, where when the distance increases, the gravitational force decreases.
Assalamualaikum and good afternoon. I am Aisyah Azhar, broadcasting live from breaking news of Berita Geo Loani. Due to the latest issue of king tide that greatly said to be the main cause of flooding in Pahang and Sarawak recently, many people were wondered what actually it is and how dangerous it can be. Basically, king tide is the highest predicted high tide of the year at a coastal location. It is above the highest water level reached on an average day. King tides occur when the orbits and the alignment of the Earth, Moon, and Sun combine to produce the greatest tidal effects of the year. It is formed when the Sun is very close to the Earth, essentially in the new moon or full moon phase. It called as perigee as its gravitational pull is at greatest. The moon has more influence on the tides than the sun does, but when the sun being closer to the earth, perihelion, it also exerts its big gravitational pull on earth, similar with moon. So, when the sun, moon and earth line up at perigee and perihelion, which happen twice each year, the gravitational force on the earth is strongest, creating the huge tides where the magnitude will come in the shape of storm, which could produce flooding. So this phenomenon will be a threat to our community safety. As a concerned citizen of Malaysia, we hope people will take this info as awareness to be more careful because this phenomenon might occur again in the future. That's all for now. We will be back with some more updates. Until then, stay tuned.
So, how gravity is related to geology? The geology itself infers the gravity of the surface of Earth as it varies with the distribution of the mass materials below. In gravity surveying, subsurface of geology is investigated based on the variation in the Earth's gravitational field arising from difference of density between subsurface rocks, which is called as density contrast. So we will measure the difference in the density of the subsurface below as different rocks has different density.
Welcome back to Gravity Method Show with our invited scientists today, Mr. Ameng and Miss Lina. Good morning. So, what do you guys have for today?
Thank you, Aisha. So we are going to explain about gravity method that I use in few applications such as gravity data and microgravity method. Gravity data method is used to locate fault. A fault is a crack in Earth's crust which typically is associated with the boundaries of Earth's tectonic plate.
While microgravity method is used to locate cavities. Cavities is formed in certain rocks such as limestone in which percolating solution have filled with valuable minerals.
Okay, I see. How do we apply gravity method to locate fault?
Gravity method used in this application involve vertical gravity data by measuring the Earth's gravitational field on the specific location on the Earth's surface to determine the location of subsurface density variation. The gravity method works when the buried objects have different masses which cause them to have a greater or lesser density than surrounding materials. But to locate fault in depth is difficult by using vertical component of the gravity data only. The existence of fault might be guessed from strong gravity gradient if the fault produced a sharp discontinuity in density distribution and had a large vertical throw. Commonly, fault detection analysis is performed by the amplitude of the analytic signal, the shaded relief of anomaly maps, and also the first and second vertical derivative anomaly maps. The result of the analysis is an interpretive image of the fault on the XY plane, displaying fault traces on the Earth's surface.
Okay. How about cavities? How do we apply it?
A cavity will create an anomaly due to density contrast between the cavity and the host rock. So microgravity method is used when the area of the survey is small and when the objective of the survey is to locate local anomalies. A cavity in limestone can either be filled with air, water, or debris. If there is sufficient change in density, the gravimeter would then record a gravity load on top of the cavity. The best response would be from an unfilled or air-filled cavity because of the height contrast in density between air and host rock. A gravity height is produced if the subsurface density contrast is positive. Where the target is denser than the host rock, such as the presence of pinnacles or subsurface topography heights, the gravity data must be reduced to remove external factors affecting the reading other than the local gravity anomaly. Correction that must be applied to raw gravity data are drift correction, free air correction, and latitude correction. The data also must be separated from the regional anomaly caused by the gravity effect in the micro scale before any interpretation.
Okay, next question. What is the significance of these studies?
Fault locating is important in mineral and petroleum exploration as they may either seal or act as barrier to fluid flow, or may be important conduits for migration of petroleum and mineralization fluids. Many mineral deposits are fault and fracture control. Recognition of fault is also important in hydrogeological studies as fracturing along faults may produce hard rock aquifer.
Cavities locating is important for the development purposes because cavity can affect the physical properties of the surrounding rock mass, hence give rise to a far larger anomalous zone that can be produced by the cavity on its own. It is also important to avoid any hazards such as sinkhole which can destroy buildings or roads so that there will be no accident happen in future.
Thank you for the brilliant explanation. Next, let us welcome Miss Kila and Miss Shaza as lab assistant for Mr. Ameng and Miss Lina to elaborate more on how the data is collected and processed.
Before I explain more detail on the methodology, let's take a look on these 3 methods on data acquisition. The first one is falling body measurement, second one is pendulum measurement, and the third one is mass on spring measurement. We can measure the gravity acceleration from falling body measurement by dropping an object and measuring its acceleration as it falls. For pendulum measurement, we measure the period oscillation of a pendulum. And for mass on spring measurement, we suspend a mass on a spring and observe how much the spring deforms under the force of gravity. Based on all of the 3 methods, the mass on spring method is the best method to collect data as it provides constant gravity acceleration and less time consuming.
No, we cannot use the data obtained directly from the field. Why? Because there are some sources of error and noise that can affect the data. Any movement that can cause the ground to vibrate or shake will affect the data. For example, an earthquake. To get a better data, we need to fix or correct the error. It is known as gravity data corrections. There are 5 common gravity data corrections, which are drift, tides, latitude, free air, and Bouguer corrections. Drift and tide correction are related to time variations, while latitude, free air, and Bouguer corrections are related to space variations. Drift and tide are usually corrected by doing a looping method. The gravimeter is the perfect instrument that removes all drift and tide effects automatically. Latitude correction is needed due to the changes that result from variations in the observed gravity taken at different latitudes or at distances from the equator. Free air correction is made when the height between the station and the sea level differs. Then, we will select a reference elevation that is sea level and change our readings to be what at that elevation they should be. Bouguer correction contributes gravitational attraction of the mass above sea level. Mountainous areas will have additional mass which will appear to increase the value of gravity. The corrections will eliminate the influence of the additional mass above sea level that either adds to the gravity observed or subtracts from the gravity observed. After some corrections, only then we can interpret the data. I will pass it back to Akila for data interpretations.
After we have done the corrections, we will need to interpret the data. In other words, we will need to translate or explain the data. We will be using a gravity contour map and a gravity profile as an example to translate the data. Based on the north and southwest part of the contour map, we can see far apart dots which are the gravity stations. These are the regional studies area. Our main objective is to find the residual areas which are the connected lines. Next, the data collected must be good and sufficient and has already been corrected using the corrections based on the objective. Rock samples are also collected to identify the rock densities. This will give a good data depiction of the area. After that, a data modeling is constructed by using software based on the objective. If it's a contour map, then it is not needed. If we want to find the depth or thickness, then a geological modeling is wanted. In this case, it is not needed. To test the data model, we compare the Bouguer anomaly values calculated by the model with measured values. Modeling is basically just trial and error. If the model does not fit, we will need to alter the model until we get an acceptable fit. Note that many different models can give similar gravity values. The best thing we can do is to reduce the uncertainty or ambiguity. The number of potential geometries that will generate appropriate curves is rapidly increasing as the geologic controls decrease. There are a variety of techniques available to limit the possible choices of model parameters.
Oh, every time I see you, 그대 눈을 볼 때면 자꾸 가슴이 또 설레어와
君とさ